This video will go through subtopic 5.3, classification, specifically going through how to create your own dichotomous key. So the skill this is related to is constructing a dichotomous key for use in identifying specimens. To begin with, we'll first recall that a dichotomous key is a series of steps, each involving a decision, which can be used to identify unknown organisms. The key prompts us to decide, through careful observation, whether or not a specimen displays particular visible features, and allows us to distinguish between specimens on this basis. When constructing a key to identify organisms, first, examine each specimen in the set carefully and choose a characteristic that is present in about half of the individuals and absent in the others, which can be done from creating a matrix of characteristics, which we will cover in a bit. This will divide the specimens into two groups. For each group, another diagnostic feature must be chosen whose presence or absence divides the specimens into two further groups. This is repeated, progressively dividing the groups into smaller and smaller groups. A branching tree diagram can be constructed where at the end of each branch a single individual is identified. The tree diagram can then be used to create a written key in which the branch points are expressed as alternative statements. Each alternative either names the identified specimen or leads the user to a subsequent pair of statements until an identification is reached. So we'll go through an example of constructing a dichotomous key. Here we have a collection of leaves that we will use to construct a dichotomous key. Note that each leaf and the tree that it belongs to has a letter assigned to it that allows for easy identification when constructing a matrix of characteristics and a tree diagram. So first, each leaf is carefully examined and the most significant features of structure are listed in a matrix. So here is our matrix, and in this matrix, their features and structures are noted by presence or absence being recorded against each specimen. So here in our matrix, we have each tree specimen listed and the associated letter that goes with it. And then here we have our list of features. And so just by examining the leaves, features are decided upon, where about maybe about half are present or absent, or just features in general are included here. And so for each feature listed, if it is present in the leaf, this is denoted by a check mark. If it is absent in the leaf, this is denoted by a dash. And so each leaf is examined for the presence or absence of this feature, and this is recorded in the matrix. This is done for each feature that has been noticed for these leaves. And you can see that, for some of them, it's about half that may be present for that feature, half are absent. For some of them, it's only present in a small number, such as, for example, leaflet paddle-shaped, widest near one end, but absent in the others. And so this particular feature could be used to help identify this leaf towards the end of the tree diagram. So from the matrix, a tree diagram can be constructed. So from the matrix, a characteristic shown by half or thereabouts of the leaves is selected. This will divide the specimen into two groups. A tree diagram is constructed, progressively dividing the specimens into smaller groups. Each division point is labeled with the critical diagnostic feature. So in our tree diagram here, at the start, we have all 8 leaves present. We choose one diagnostic feature or one characteristic that will divide these leaves into two groups. About half of the leaves go into one group and about half will go into the other. In this case, it works out that, it's half and half. Exactly. So, the structural feature is like the whole leaf, or the leaf divided into leaflets. And then each leaf that falls into these two categories are placed here by their identified letters. And so if we look at leaf divided into leaflets, here another structural feature is chosen that will further divide this group by about half. So of these leaves that are divided into leaflets, the leaflets radiate from one point, or the leaflets are arranged into two rows. And then the leaves that show these features are then placed into these categories. And then from there, we choose another structure that will further divide this group, allowing identification here at the end. So the leaflets are paddle-shaped, and the leaflets are boat-shaped, and this feature will allow us to identify or distinguish between these two particular leaves. So from the tree diagram, this can be then used to create a dichotomous key. So finally, a dichotomous key is constructed, reducing the dichotomy points in the tree diagram to alternative statements to which the answer is either yes or no. Each alternative leaf is given a number to which the reader must refer to carry on the identification until all 8 leaves have been identified. So in our dichotomous key here, we start very general. So we have all 8 leaves that we're starting with. So, the first set of alternative statements are the leaves are entire, or the leaf blade is divided into leaflets. If the leaf blade is divided into leaflets, we are instructed to go to question 5. So in question 5, the alternative statements here that we have are leaflets radiate from one point, leaflets arranged into 2 rows. And so if our leaflets are arranged into 2 rows, we are instructed to go to question 7. And then in question 7, our alternative statements are that the leaflets are 5 or less in number, or the leaflets are more than 10 in number. If the leaflets are 5 or less in number, this leaf can be identified as the pignut hickory, and if the leaflets are 10 or more, this is a picrasma leaf. And so once we've identified these 2 leaves, we can then go back and keep using this dichotomous key to keep identifying each leaf until each leaf has a name associated with it. And just note that each alternative statement is associated with a number that will allow the reader to refer to a particular statement. So this is the end of this video for constructing your own dichotomous key. Please refer to the assignment page for details about what to include for creating your own dichotomous key.